All right, ladies and gentlemen, hopefully more members of the committee will show up so that they can see this video that I propose. Oh, here, people are wandering in. So let me begin a little explanation about this video, which is entitled Why We're So Bad at Recycling Plastic. This whole issue area of the failure of recycling has been uppermost in my mind, and I'd intended to have an interim study headed up by Delegates Lafferty and Delegate Casserly, but both of them cruelly abandoned me and the committee and left the legislature because, I don't know, they're getting jobs that pay them more money. I don't know what the deal is. But in any case, that is an effort that we are going to undertake in the interim after sine die this year. But I think during the interim, I saw this video, and my first thought was, is this scientifically accurate? So I ran it by our brain trust, which is the University of Maryland Center for Environmental Studies, and I gave it to UMCs, and I said, run this by your scientists and doctoral students, and they did. They ran this video by, I think about 7 people looked at it, and they signed off. They said this video is very accurate, and the reason I want to play this, it's only 5 minutes, rather than having a long, tedious public hearing on the whole issue of recycling plastics. I thought I'd run this video. It's 5 minutes, and I think it should begin a thought process that I think we have to go more and more into, and that is to ask the question of, is recycling the best way to deal with waste? If it's not, what is a better way? And I think we have to do that sort of an evaluation and be very careful. So with that explanation and seeing a critical mass of the committee being here, let me get us started.
Look around you right now. How much plastic is within reach? Plastic is literally everywhere. Scientists have found it in the deepest depths of the ocean and on top of the most remote mountain peaks. Since the end of World War II, we've produced more than 8 billion metric tons of plastic. Of all that, only about 9% has ever been recycled. But it's not just because humans are lazy or bad. So let's take a look at what makes something that's so vital to modern life also difficult to reuse. Think about a plastic water bottle, like the kind you might buy at an airport. It's estimated that around the world, people buy 1 million plastic bottles every minute. And it's easy to think of a plastic bottle as being made of a single thing, which is the first problem. We use the generic word plastic to refer to a bunch of chemicals that are actually really different. Broadly speaking, plastics are polymers, which is a fancy way of saying they're repeating chains of molecules. During their formation, they can be processed into arbitrary shapes, which is what gives them such a wide range of applications. Now, every plastic material falls into one of 2 groups, thermoplastics and thermosets. The individual links in a thermoplastic are held together by relatively weak chemical bonds. When the material is reheated, the molecules can break free from those bonds and take on a new shape. But in a thermoset, the polymer chains form intricate networks with tight bonds. Heating these materials enough to break the network destroys the plastic itself. So while thermosets can be very strong, they can be difficult to recycle. There are a lot of different types of thermoplastics in commercial products, but 2 of the ones most commonly seen in the United States are known as PET and HDPE. PET, or polyethylene terephthalate, is clear, can withstand moderate temperatures, and resists cracking, while HDPE, or high-density polyethylene, can survive more extreme temperatures, but generally lacks the transparency of PET. Both of these plastics are used for ordinary bottles, but the trouble is that not all recycling centers accept both of them, so you need to know what kind of plastic you're tossing out and what types your local recycler accepts in order to dispose of one correctly. Even then, you're probably still doing it wrong, because a single product often combines multiple kinds of plastic. For instance, the twist cap on that bottle made of PET can often be made of polypropylene, yet another type of plastic. And since most of us don't carefully disassemble our trash before getting rid of it, recycling plants need a way to separate all the plastics they receive. And it can be critical for this separation to be nearly perfect. For example, if the plastic PVC gets recycled, it can create acids that damage and discolor PET beyond repair. And all it takes is a single PVC bottle in a pallet of 10,000 PET ones to ruin the whole batch. To avoid these problems, recycling plants have a few ways to sort plastics. One approach is to use density. When immersed in water, PET sinks, while some other plastics float. Another option is heat. Different plastics become soft at different temperatures, so precisely heating the mixture can set the various materials apart. But since even a tiny bit of contamination can do a lot of damage, recycling properly gets expensive, sometimes too expensive to be worthwhile. For instance, in New York City, every ton of recyclables costs $200 more to recycle than it would cost to just toss in a landfill. But here's the thing. Even if we invented a process that magically and flawlessly sorted and processed every kind of plastic, recycling would still be hard. That's because unlike metal and glass, plastic degrades every time you recycle it. Aluminum, for instance, is an element, so no matter how many times you melt and rework it, you've still just got aluminum atoms. On the other hand, at the microscopic level, plastics are really long chains of molecules. For example, HDPE, one of the plastics we do recycle, can contain up to 100,000 linked ethylene molecules. And every time a plastic is reheated to form it into something new, some of those chains break, reducing the quality of the material. To get around this, manufacturers add new plastic to the mixture, so even recycling plastic requires new plastic. Another technique for prolonging the life of plastic is downcycling, which turns the material into increasingly less sophisticated products. Plastic that starts as a water bottle might then be turned into fleece for a jacket, before ending its life as plastic lumber in a deck. Eventually, even that isn't enough, and whatever's left gets burned for energy or thrown into a landfill. So, in a sense, there's no such thing as plastic recycling. Every bit of plastic ever made will eventually end up as waste. And in many cases, it's not possible to do even one round of recycling. And that's a big deal, considering that in 2009, about 4% of all the oil and gas extracted worldwide was turned into plastic, and another 3 or 4% was used to create the energy for that production. Now, people probably aren't going to give up plastic, and there are some good reasons to keep it around. It has huge benefits for health, accessibility, and food safety. But we can be better about how we use it, and that means developing new recycling techniques that prolong the life of the plastic that we have, cutting out single-use products where we can, and being careful about which plastics we use and how we combine them. Thanks for watching this episode of SciShow. If you want to find out more about what happens behind the scenes to the plastic that you do recycle, you can check out a video that we made all about that.